This mini lecture serves as an introduction to the stereochemistry of nucleophilic substitutions. Now I know we've seen this before, but it's a useful tool for allowing us to see the differences between SN1 and SN2 substitutions and the stereochemistries of their products. So let's look at SN2 first. Again, we've got our illustration of the backside attack and the inversion of the stereochemistry. We'll see a bit more of that in a second. Now watch as we know that the nucleophile comes in, attacks from the back, and twists the compound so that it's like an umbrella on a windy day. It turns inside out. Now you can see that what's going to happen when this comes in and attacks from the back, the product we get, and it'll be a single product, will be the exact opposite stereochemistry to what we started with. So there you go. The product looks like this and the reactant looks like this. If you had a mirror down the front here, you can see they're basically like enantiomers. They're not really enantiomers because these two things are different, but they're like enantiomers. The point being they do have opposite stereochemistries. If we started with an S reactant, we'd end up with an R product. If we started with an R reactant, we'd end up with an S product. Now let's look at the SN1 reaction. In the first step of an SN1 reaction, the leaving group leaves, leaving this planar carbocation. Nucleophile can attack from this side or from this side. This leads to a 50-50 chance that we could get either product, which leads to two possible products being gained by this reaction. And these two products are mirror images of each other and are thus enantiomers when this was a chiral center. So if you started off with an R reactant, you would get an R plus S product. If you started with an S reactant, you would end up with an R plus S product. And that's the story that I have here. So this is the SN2. We have inversion of stereochemistry, R reactant, S product, S reactant, R product. SN1, we end up with what's called a racemic mixture. That's a 50% mixture of R, 50% mixture of S. We start off with an R reactant, we'll get R plus S products, and S reactant, R plus S products. So for SN1, regardless of the stereochemistry we start with, we always end up with the same thing, R plus S.